Welcome to Brain Vision.
So let's draw a cross section of the Earth, essentially. Just do a little bigger. And we can say, let's try to do it a little bit more perfectly. We can say from here, this distance here would be r, the radius of the Earth, and then we can cut out half a semicircle and say that this would be theta according to the alternate interior angle theorem. This also would be theta, and we can consider this distance here r, with, of course, this distance still being the radius of the Earth. Now, each location will have the same angular velocity, 1 revolution per day, but the radius of the circular path varies with the location. So from this diagram, you can see that the radius of the circular path for that particular location would be equaling r cosine of theta, where theta would be the latitude. And so we can say that here, for part A, we have the velocity equaling omega times r. This would equal 2 pi r divided by t, the period. And so this would be equaling 2 pi radians for every 1 day. This would be multiplied by 1 day for every 86,400 seconds, and then multiplied by r, the radius at that particular location, 6.38 times 10 to the 6th units, of course, meters. And so V would be equaling 464 meters per second. For part B, we have a latitude of 66.5 degrees. So V would again be equaling 2 pi radians for every 1 day. This would be multiplied by 1 day for every 86,400 seconds. This would be multiplied by 6.38 times 10 to the 6th meters times cosine of 66.5 degrees. And this is equaling 185 meters per second. This would be our answer for part B, our answer for part A, and then finally for part C, we have the velocity would be equaling 2 pi radians for 1 day multiplied by 1 day for every 86,400 seconds. And then this would be multiplied by 6.38 times 10 to the 6th meters and multiplied by cosine of 45 degrees. And V for part C is equaling 328 meters per second. This would be our answer for part C. That is the end of the solution. Thank you for watching.